All right, in this video, we're going to explore how Coulomb's law works. So remember, Coulomb's law just says that the force between any two charges can be calculated by multiplying the two charges together, divided by their distance squared, and then we also have this proportionality constant, which we're going to leave off for now. But basically, the bigger the charges, or the bigger the product of the charges, and the closer the distance, the larger the force is going to be. So in this situation, we have two charges that are repelling each other with a certain amount of force right now. We don't care how much that force is, but what we're trying to do is see that if I change some things, if I double one charge, quadruple another, and double the distance, how will that change the force? So one thing we can do is just start with a baseline. Let's imagine that the current charges are 1. So I'm going to have 1 times 1, and the current distance is 1. So we're just going to ignore the k for now. But 1 times 1 over 1 squared gives you 1. So this is the current situation with the current distances and current charges. Then we say, okay, we're changing something. We're doubling one charge and quadrupling another. So Q1 then is going to be, instead of a 1, it's going to be a 2 because it's been doubled. And Q2, we've quadrupled this charge, so it's going to be 4. So now we're just trying to see how things have changed. So we have 2 times 4, and the distance has also doubled. So D, instead of using 1, we're going to use 2, but notice that it's going to be squared. So we're just going to figure out what this equals. So 2 times 4 is 8. 2 squared is 4, so 8 divided by 4 is 2. So what this tells us is that if you were to have a force between two charges and it equaled, some amount, if you then doubled one charge, quadrupled the other, and doubled the distance, your new force would be twice what the old one was because 2 is double 1. And that's sort of the process. Let's do another one. So in this situation, I have two charges. They're attracting each other. By the way, it doesn't matter if they attract or repel. It's the same magnitude of force. But it says one charge is cut in half, the other is tripled, and the distance is cut in half. So again, the baseline is these are all 1. So 1 times 1 over 1 squared is 1. So now I am cutting one charge in half. So I'm going from 0.5, from 1 to 0.5. I'm tripling the other. So I'm going to put a 3 in for the other one. And then I am cutting the distance in half. So I'm going to put 0.5 in for my distance, and again, I'm going to square that. So 0.5 times 3 is 1.5. 0.5 squared is 0.25. And if I divide these numbers, I'm going to get 6. So what this tells me is that the new force is 6 times what the old force was. So if you have a certain amount of attraction, one charge gets cut in half, one gets tripled, and the distance is cut in half, the new force will be 6 times the old force. Let's do one more type of this problem. So this one's about the same. You have two charges, but now they're actually telling us the force. And they're saying, okay, what if both charges are doubled and the distance is tripled? What will the new force be? So we're going to ignore the current force for now. We're just going to do the same analysis we've done. We've got the initial conditions where everything's 1. And then we say, okay, both charges are doubled. So for Q, we're going to put a 2 in for each Q. So Q1 is going to be double what it was, and Q2 is going to be double, and the distance is tripled, so 3 squared. So 2 times 2 is 4, 3 squared is 9. So the new force is going to be 4/9 of whatever the original force was. So it tells us the original force was 9. So if the original force is 9 and the new force is 4/9 of that, we're going to multiply by 4/9. So 9 times 4/9 equals 4, because it's really like 9 over 1. These cancel, you get 4. So that means the new force would be 4 newtons. So if you're ever asked to actually calculate the new force, you're just going to take this factor and multiply it by the original force. So if this had been a 2, you would double the 9 and get 18, etc. So anyway, that's how we do what we call proportional analysis. You don't have to worry about the k. We don't have to worry, actually, using that value. We're just seeing how things change from the original conditions to the new conditions. So give that some practice with the worksheet and with the quiz and see if that makes sense to you. So until next time, I am Derek Genova. Have a delightful day.